This section examines injectors. In engines with multi-point injection, the injectors inject fuel into individual intake tubes, directly in front of the engine intake valves. The injection valve or nozzle valve is held against the valve seat by a helical compression spring. A movable plunger is rigidly attached to the nozzle and supported in a guide in the lower section of the injector body. The plunger is acted on by a solenoid winding wound onto the injector body. Each end connects to a terminal. The control unit completes the injector electrical circuit. It provides pulses of a set duration so that the injector valve opens and closes or pulses very quickly. Electrical pulses pass through the injector winding and set up a magnetic field that draws the plunger and valve away from the nozzle seat. Fuel held under pressure in the fuel rail can now pass through the filter and the center of the injector and enter the inlet port. In a single-hole injector, fuel is injected in a finely atomized conical spray at an angle of about 25 degrees. The exact injector open time depends on the data the sensors give the ECU, but it usually varies from 1 to 20 milliseconds. Valve lift for the fully open position is about 0.15 millimeters and response time is about 1 millisecond. Rubber moldings or O-rings seal the injector in the manifold and at the fuel rail. This helps prevent the transfer of heat to the injector and the formation of fuel vapor bubbles under heat-soaked conditions. Director plate injectors operate on the same solenoid principle. 4 minute holes for fuel delivery direct jets of fuel toward each other so that they collide and break up into a cone-shaped spray. In some engines with 2 intake valves, the injectors have 4 holes but only 2 jets directed towards each valve. This ensures good fuel distribution for efficient combustion and emission control. The jets are set very precisely, and they must be located accurately by means of the fuel rail.